السلام عليكم جميعا. Today our lecture is analytic statistics. By the end of the lecture, students should be able to define statistical inference, define significance level, critical value and p-value, define one-side and two-sided test, list two of statistical hypotheses, define two possible errors, come to the wrong conclusion, list steps of hypothesis testing. As we know, analytic statistics is part of statistics. We have two types of statistics, analytic and descriptive. We know that descriptive statistics is that type of statistics that help us in describe and understand the features of specific data concerning sample or population. Analytic statistics is statistics that help us to get conclusion about specific sample data or population data. Statistical inference. What do we mean by inference? Inference استدلال الإحصاء. Statistical inference استدلال الإحصاء is a procedure where inference about population is made on the basis of the result obtained from sample down from that population. So we reach conclusion about the population by studying the data of the sample. This sample is drawn already from the population. Statistical inference is achieved by estimation or hypothesis testing. So there is two ways to do statistical inference, either estimation or hypothesis testing. Statistical inference. Estimation. Estimation is the procedures used to calculate the value of some property of population from observation of random sample drawn from that population. We take certain observation of the random sample and we try to calculate the value of the same property within the population. And we have two type of estimation: point estimate and interval estimate. Point estimate, single numerical value obtained from the random sample used to estimate a corresponding population parameter. For example, the standard deviation of the sample, denoted by S, used to estimate the corresponding population parameter, which is sigma, or the mean of the sample, which was x bar. The sample mean, which denoted by x bar, used to estimate the population mean, which denoted by mu. Or interval, we have also what's called interval estimate. Interval estimate, here we have two numerical value. Okay, we have two numerical value within which we suspect that the parameter of the population lie within with a specified degree of confidence. So we have two value. For example, we say 2 to 10. This two value, okay, this represent this two numerical value defining interval range from 2 to 10, from 2 to 10, this range, okay. Here we suspect that the parameter of population will lie here, 2, 3, 4, 2 points. And usually we use specified degree of confidence. Usually we use 95%. And when talking about this, we say we are 95% confident that the population parameter, the mean of population, is lie within the confidence interval, or within this range of value. Hypothesis testing. What is the purpose from hypothesis testing? The purpose of hypothesis testing is to help the researcher in reaching decision corresponding a population by examining sample from that population. He put hypothesis, concert, sample, data, and find some association or relation between this data, and he tells this data or this association to reach decision whether there is association or there is no association. Hypothesis, we have research hypothesis and statistical hypothesis. Research hypothesis is the assumption that motivates the research. It is usually the result of long observation by researcher. The researcher observed something or observed many things, many factors that may precipitate to something. After that, he put hypothesis, he put assumption about this observation. And this hypothesis led directly to the second type of hypothesis, which is statistical hypothesis. Statistical hypothesis is stated in a way that can be evaluated by appropriate statistical technique. So, statistical hypothesis will be in two types: null hypothesis and alternative hypothesis. Null hypothesis, we denote it by H or by H0, and alternative hypothesis H sub A. Null hypothesis is a particular hypothesis under test. We test the null hypothesis and we accept or reject the null hypothesis. Okay? But what we want to prove? We want to prove the alternative hypothesis. Usually, the researcher concerned with the alternative hypothesis. He tests the null hypothesis, okay, but he wants to prove the alternative. Usually, he wants to prove the alternative hypothesis. Now we come to some fundamentals of hypothesis testing. Errors. When we reach a conclusion, there's some possibility that this conclusion is wrong. This comes from two possible errors. The first one is called alpha error. Alpha error means what? The null hypothesis, rejecting the null hypothesis when it is true. So the hypothesis of no difference is true, but we rejected it. This rejection is called alpha error. If we look to it, it will be the same like alpha. We reject the null hypothesis. Okay, this is the first type of error. The second type is the opposite to the first type. Here we accept the null hypothesis when it is wrong. In the first type, we reject the null hypothesis when it is true. In the beta, or in the second type of error, we accept the alpha. We accept the null hypothesis when it is false or wrong. Significance level and a critical value. Significance level is also the other name for alpha error. True. Significance level means alpha error, type 1 error, rejecting the null hypothesis when it is true. Significance level, usually we use either 5%, either 0.05, which is the commonest one, 0.1. Significance levels. The significance levels also denoted as alpha. So the type 1 error, which is denoted as alpha, so type 1 error is called significance level. The significance level usually we use 5%. Okay, this is the common significance level used. Also we have 1% or 0.01, but the commonest one is 5%. The other thing is a critical value. What do we mean by critical value? Critical value is the cut-off value between the acceptance zone and rejection zone. Here, as we see in this diagram, okay. The significance of level, we decided it, okay. We decide we adapt 5% or 1% or 0.01. So we decided the significance level from the start. A critical value, for each significance level there is a critical value. This critical value, we call it tabulated value. Tabulated value, we get it from the table concerned with each test that we used, okay? For example, for that test, the 5% significance level of 5% will be equal to 1.96. The critical value will be 1.96 for the significance levels of 5% in that test. So this critical level, this critical value will separate between the acceptance area. This is called acceptance region, and this will be the rejection, okay, region. Here, this is the rejection region, and this acceptance region or non-rejection region. If the computed value, when use the test statistic which is suitable for our problem, if the tabulated value bigger than the calculated, so the calculated will be in the acceptance region, it will be here. If it is smaller than a critical value, okay, if it's smaller than critical, it will be fall here in the acceptance. So we accept the null hypothesis and reject the alternative. But if the calculated is more than the critical value, if it is more than a critical value, it will be fall here in the rejection area, okay. It will be more than the critical value, and we reject the null hypothesis